today we're going to talk about vertical circles. As you can see here, I have this circular track. This track is a track that has no magnets in it. I have a steel ball, and when I place that ball on the track, there is nothing holding that ball in place. Literally just falls off. Wherever I place it, the ball just falls. Gravity pulls it down. And so what we're going to do is we're going to place on this track the ball, and we're going to just watch and see what happens, and then we'll discuss it. So here we go. You see the ball go through the loop, and it stayed attached to the loop, and it did not fall. So why does that happen? Well, the answer to that is that as the ball is coming down the track, it is gaining kinetic energy. It goes from having gravitational potential energy to gaining kinetic energy. And so the ball is moving pretty fast when it gets to the bottom of this track. At this point, the ball wants to continue downward, but the track itself pushes up on the ball, causing a centripetal force. That upward push causes the ball to change its direction. So instead of going down, the track itself is pushing up, and the ball starts to move in that circular direction along the track. Every time the ball changes direction, the track is there again to push inward. And so when the ball is on the side, the ball wants to go straight up in the air, but the track is here preventing that, pushing it inward. While the ball is traveling in its path, it is losing its kinetic energy and gaining additional potential energy, regaining that potential energy. And so when it gets to the top, it is moving slower than it was when it was at the bottom, but it is still moving fast enough to stay in the track. And so what we find is that there is a minimum velocity that this ball can have before it does this. You see it drop off? That happens because the ball is not moving fast enough at the top of the circle. Watch again. So to get the ball to move fast enough to stay connected to the circle, we need to say that the centripetal force in this track is equal to the weight of the ball getting pulled down. And when we solve that equation out, we find that the minimum velocity that the ball can be moving when it is at the top of the track is equal to the square root of gravity times the radius of the curvature. And so the bigger the radius of the curvature, the faster the ball has to be moving to stay attached to the track when it's right at the top. As the ball moves through the track, when it gets back to the bottom, again, there's a centripetal force on it, and that centripetal force on it has to be equal to the amount the track is pushing on it with, as well as the weight of the object. And so we find that at the bottom of the track, there is a very large force, a force greater than its own weight, acting on it, because again, as it's coming out of the curve, there is going to be a force to force it out of the curve, as well as a force to overcome its own weight. Once it gets on the level track, then it has stopped going through that centripetal circular path, and the velocity it has does not affect its weight, its apparent weight, but the track itself is still pushing up with a force equal to its weight, otherwise it would be falling through the table. So again, as we let this go, there is a magic velocity that is equal to the square root of GR, and as long as we stay above that velocity, when the ball reaches the top of the track, the ball will keep connected to the track and stay in its circular path. Here we go. The last piece of this is what happens as it's going faster. And when we get that ball moving faster than GR, square root of GR, then the track has to provide additional force. And so if you were riding a roller coaster like this, when you got to the top of the roller coaster, if you were at that minimum velocity, and you had a scale that was located on your seat, the scale would read 0. It would read that you weighed nothing. But if you're moving faster than that minimum velocity, the scale, which is pushing down, actually will start to read more than 0. It would read more than 0 because there has to be some force to keep it in the track. Otherwise, you're going to launch out of the track with your inertia. So again, if we're going the minimum velocity, we are going to stay in the track. If we're going more than the minimum velocity, we're going to stay in the track, and we're going to have some apparent weight that's actually pushing downward. If we're going less than the minimum velocity, we're going to fall off the track. If you have any questions, as always, let me know. Have a wonderful day.